Welcome to Unit 4, Lesson 18, the quadratic formula and complex solutions. Let's use the quadratic formula to find complex solutions to quadratic equations. Okay, so here is the quadratic formula. When you have a quadratic equation, ax squared plus bx plus c, you first have to identify a. A is the number in front of the x squared term. B is the number in front of the x term. You might not always have a b. And c is the number in front of, is the constant that has no x after it. So you might not always have a c. You have to have at least an a for it to be quadratic. Then here's your formula. The b term, the negative of the b term, and be careful with this. We're going to see that you must use parentheses to keep your sign straight. And then plus or minus the square root of b squared minus 4ac all over 2a. Now we have to remember, when numbers are next to letters, it means multiply. The order of operation is multiply. So let's remember that, as long as a is not equal to 0. If a is equal to 0, it's not a quadratic equation. Okay, here's an example of the substitution. Our a was -3, our b was +6, our c was 5. They chose not to put the b in parentheses because of the sign. They put the a in parentheses because it had a sign in front of it. I prefer not to do that. If it was me, I would put every term in parentheses so that you're not confused about the signs. That's just my habit, and I'm going to do it that way. Okay, mentally decide whether the solutions to each equation are real numbers or not. So when you take the square root, we know we can't take the square root of a negative number because it's complex. So this is not real. If I subtract 25 from both sides, x squared equals -25. This will give you not real solutions. We can take the square root of this, and y plus 5 equals 0. I subtract 5, I get one real solution. So this is real. And again, when we take the square root of a negative number, it's not real. So these are non-real solutions for 3 out of 4 of them. Okay, so first things first, step 1, identify your a, your b, and your c. Your a is 1. If there's no number in front of a letter, the number is 1. Okay, so they jumped a couple of steps here. So we have to remember our formula. Our formula is x equals -b plus and minus the square root of b squared minus 4ac all over 2a. Then we're going to do the substitution. So they jumped to step 3. Step 1, identify your a, b, and c. Step 2, do your substitutions. So watch how I do my substitution. My b is -12. Be careful. The sign in front of the term goes with the term. So negative of -12 plus and minus the square root of -12 squared minus 4 times a, which is 1, times c, which is 41, all over 2 times a. I get 12. Negative times a negative is a positive. 144 minus 164 over 2. Then I get 12 plus or minus the square root of -20 over 2. Now, I'm going to have to break this -20 down. We'll do that on the next page. So the whole thing was 12 plus or minus the square root of -20 over 2. All right, so 144 minus 164 is -20. The square root. Now I have to simplify my radical. The first thing, I'm going to separate the -1. And then I have to divide 20 into a perfect square and another number. The only perfect square that's small enough to divide evenly into 20 is 4. And then 4 times 5 makes 20. Now, when I simplify this, the square root of 4 is 2. The square root of negative 1 is I. And root 5. So now putting this all together, we have 12 plus or minus 2I root 5 all over 2. So now what I'm going to do is see if I can take a 2 out. 12 divided by 2 becomes 6. 2 divided by 2 becomes 1. So that's just I root 5. I factored out a 2 so that they can cancel out. And my answer is 6 plus I root 5 and 6 minus I root 5. Okay, so what I'm going to do is I'm not even going to worry about trying to factor one like this. I'm just going to use the quadratic formula. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a, negative of negative 10 plus or minus negative 10 squared minus 4 times 3 times 50 all over 2 times 3. I should have taken the time to identify my A. My B is negative 10, remember, and my C is 50. The sign in front of the term goes with the term. So a negative times a negative is a positive, so I'll get 10 plus and minus the square root of 100 minus 12 times 50 is 600 all over 6. I get 10 plus and minus the square root of 500 over 6, negative 500. Oops, that's negative 500, which equals 10 plus or minus, I'm going to separate this into negative 1 times 5 times 10. 100, I'm sorry, times 100. All over 6. So this gives me 10 plus and minus. The square root of 100 is 10. The square root of negative 1 is I, root 5, all over 6. There's a common factor of 2 because on standardized tests like the SAT, you're going to have to go further. You're not going to see this as an answer. So if I factor out a 2, I get 5 plus and minus 5I root 5 all over 2 times 3. I cancel out the 2's, and I get 5 plus or minus 5I root 5 over 3. Yes, you're going to have to do all this work to simplify this. And we want to put this in a positive plane. I'm not going to worry about plotting these in a positive plane because it just doesn't. But if you really, 5 over 3. So what this really means is 5 over 3 plus 5I root 5 over 3 plus and minus. So 5/3 is not quite 2. It's close to 2. It's probably around here somewhere. And then 5I root 5 over 3 is probably a little under 2. So it's probably like right here. And then probably like right here somewhere, if I had to guess. But I'm not worried about plotting in a real plane. It's just not important.